Okay. So first, welcome to Berlin. This is important for us as we recently opened an office here in Berlin. So this is one of our homes. So we are not only into distributed systems, we are into distributed company. And so we have our small Berlin engineering team here today that we are actively growing. And welcome. Welcome to our friends in San Francisco. This part of the show is being sort of streamed over to San Francisco as well, where we have a sister event going on today. And welcome to the community, everybody here. Who here has used CoreOS or any of the open source projects, contributed to an issue, a pull request, contributed in the community in some form, either as a user or a developer? Anybody here? Okay, I think that's pretty much everybody, almost. Well, thank you so much for all your participation, ongoing support. So our mission as a company is to fundamentally improve the security of the internet. We believe that this becomes possible if we unlock this style of infrastructure around distributed systems and containers, something that we call GIFI, or Google's infrastructure for everyone. To do that, we've built in open source all the major components that are required to do it that don't exist in the open source world today. We call it building into the void or building in white space. And these are some of the projects that you know and use. And so we've built each of these in some form because things like them didn't exist or didn't exist in such a way that they were easy to consume or deliver in the security needs and so on. Beyond that, so we help enable GIFI in open source, but we also help businesses adopt it. Not all companies, like many of the people here, want to take the pieces and assemble it themselves. They need solutions that help them adopt it. And if we want to fully get this style of infrastructure adopted, we need to not just provide the tools, but also provide solutions. And so those are things like Tectonic, which is our commercial distribution of all of this, GIFI in a box, if you will, based around Kubernetes, Quay, which is our container registry, and more to come. So, with that, our first announcement I want to talk about today is we are using this event today to announce our Series B financing. We've raised an additional $28 million. We've partnered up with investors that get what we're doing. Namely, this is led by Google Ventures, or GV, and additionally Intel. So it's no surprise that there's a couple logos here. These also are the folks sponsoring the party tonight, so it should be a good one. So with that, I want to first kick off to our friends over at Intel to give you a little update about what they're currently thinking. So here's Das.
Hey, Alex, thank you.
All right, thank you, Das.
So thanks, I'm Das Kamhout. I work inside of Intel. Long background grid computing and building and running private clouds as well as running on public clouds. So we're pretty happy to be involved in this next disruption of what's happening with cloud computing. You know, pretty much, cloud is the norm for everywhere. Who uses a cloud today? Anybody? Okay, just a couple of you, that's good. But what we're starting to see is that there's many different types of clouds. There's starting to become not just 2 or 3 gigantic ones, but we're seeing them form across the world. And some of these are having challenges from an operational perspective. There's fragmented solutions. Some of these are hard to basically stand up. They're hard to run, and they're often missing a lot of the key features. So from an Intel perspective, what we want to see is the evolution being pushed forward as fast as possible to drive the technology forward. So fortunately, there's this cool key thing called GIFI, which is, how do we bring this forward? Is Google infrastructure for everyone else, or just let's leave it at for everyone? So the concept of Google infrastructure is very powerful, and we'll go into that to a bit. But a lot of people say Google is freaking extremely enormous. So how does this actually apply to me? But what we've seen in many situations, you can scale this down. You can actually run a lot of the concepts on your laptop, which I think many of you have experienced with Kubernetes. But it's also kind of scary. Google runs the Borg inside of their data centers. But what are we pushing forward? Skynet, Singularity. I like to think the Jetsons is better, or Star Trek. We're using these systems for good. But we still have troubles just with semantics. You can't define even elastic. People argue, what are all of these terms? But we think we're generally, going to a point now where everything is moving forward. The pace of Kubernetes has been insane. The pace of CoreOS has been pretty stunning. And the pace of this technology is moving quickly, where we think we're basically at a point now where the infrastructure is pretty darn great and something that you can use for everyone. And it's really, available now. So what is this used for? It's really used for apps and data, selfies. All the clouds are for selfies, right? Well, so actually, while this is a huge amount of the data that's on Facebook and Google, really what we'd like to see is where this technology is pushed forward for the next generation of solutions. We have this goal that you can basically prescribe medication individualized to a single person in less than 24 hours by basically the genomics research that we're doing. So we've been sponsoring this for a number of years now, and we really see the point where we can use this tech, not just for the normal stuff that we use like Uber and selfies, but use the technology, take it to a pace of innovation where it actually helps us in our daily lives even more so. And all this is built on infrastructure. So if you look at infrastructure over the last 30 years, I've been in IT for the last 20 years. I was basically born in IT. We had this traditional infrastructure, very simple. We moved to virtualized. We had this first concept of cloud, which is basically, give me a server. This is what Amazon built. And everybody was used to that concept. Meanwhile, this Giphy way, which is all container-based, process-based, worked with giant data centers, giant schedulers. It's highly optimized, and it drove up utilization. We see all these models moving forward inside of data centers, and we need to power them all. We see this path also from another perspective. I like to call the Giphy also, before there was Giphy, Cloud B. This is just the concept of hyperscale. Think of the sense of processes, and Cloud A being, give me a server. But we do believe phase 3 is the norm right now. This is where most people run. You go to Amazon, you go to Google, you run your Kubernetes on top of that. We'd like to see phase 5 that's actually flipped around, which is very similar to what Google does today. I think Google actually started with lots of containers and processes running through Borg, and then they turned on Google Compute Engine to give us basically Cloud A. So this is basically what Google is already doing, and we would like to see that move forward. So for Giphy, all the right layers are actually here. You saw stuff about Prometheus on monitoring. There's probably some cool stuff about networking and storage, but fundamentally we think all the pieces are coming together to really allow you to run this at scale. So, and if you think about the pieces and how Google operates, basically, Borg is a giant resource scheduler. It's launching all these containers instantaneously, billions of them constantly. And each of these containers are basically processes and software. Now, if you think about Giphy and what we're doing with Kubernetes, it's basically the same thing. And recently, maybe it was about a month and 10 days ago, we announced this cooperation between OpenStack and Kubernetes, between CoreOS and Mirantis, to basically push forward, take OpenStack, treat it like a process, and actually run it on Kubernetes. So that phase 5 that we envisioned. And what I'd like to do is have Alex come up. He's gonna talk a little bit about and give us a little demo about how this is gonna look.
Just gonna do a quick demo of this. And in this context, OpenStack is just an application, just like anything else. Just like OpenStack happens to be a lot of Python, and things like the hypervisor themselves. When you distill it all down, libvirt and KVM is just another process running on a machine somewhere. And so what we're able to do is take every component of OpenStack and package it up just like we could with any other application. Now, OpenStack is notoriously difficult to manage, so we chose it, one, to show how these two worlds can come together, but two, to just show that these platform, like Kubernetes and containers, are able to package really anything, even the most complex, gnarly of applications, of which OpenStack has kind of a notoriety for. So what you're seeing here are all the different OpenStack components. If you're familiar with OpenStack, some of these names will look really familiar. Horizon is the web UI, so we see Horizon here, and that's what's coming up here. So this is the actual web dashboard for OpenStack itself. And again, just think of this as another application. In this case, we just showed the web page, which that's pretty easy to imagine. That's a Django app just running in a container. People do that all the time. But in the case of this Kubernetes pod, you see things like Nova libvirt and the compute agent. So this is actually the hypervisor itself packaged inside of a container and then deployed on top of Kubernetes. And we can do this with the hypervisors as well as the networking layer, storage layer, everything. Because remember, all of these are just applications. They might be applications that talk to the kernel, or applications that are, serving up JSON, but they are all applications no less.
That sounds almost like what Google's doing, hypervisor in a container.
Yeah, I mean, our little diagram that we showed off has, the infrastructure as a service from Google Cloud, and then here it's an infrastructure as a service provided by OpenStack. It's just a way of exposing your infrastructure.
Awesome.
So, cool.
Thanks, Alex.
Yep.
So a couple things to drive home real quick there. So with Kubernetes, you can have rolling upgrades. You can basically scale out instantaneously, as well as you can basically deal with failure. So all those concepts, they're really hard to do with OpenStack. So we're bringing all those forward. And fortunately now we've actually open sourced the first part of this. So you can take part of it, basically today. It's out on GitHub, Stack and Kubernetes, bringing these two worlds together. So I encourage you to get involved. So I also talked about monitoring, and monitoring for us is really when you turn the data center into nobody's actually working inside of it. It thinks for itself. So watch, decide, act, and learn, much like a nervous system does. So one thing that we contribute initially is a watcher. So we recently open sourced a tool called Snap. It's an open source telemetry framework. We actually open sourced this at the Tectonic Summit in New York last year, but we're seeing a huge amount of traction in this. And think of it as basically a way to feed, to process, and to publish in a highly distributed fashion. Right now, this is basically showing to Grafana. There was a recent announcement, so we're working closely with Grafana team to basically drive this forward. So collecting just about anything possible, huge plugged-in architecture, processing anything, and feeding into basically any system, whether it's a message queue or database, and all at the same time. So watch, decide, act, and learn, making the data centers basically think for themselves. So what I'd like to encourage you all is to get involved now, either as users or as developers. We have Kubernetes development, OpenStack development, and Snap. And again, we opened up Stack and Kubernetes today. So thanks a lot, and thanks, Alex.
Thanks, sir. Okay, so next set of things. We want to talk about our networking project Flannel. So if you're not familiar with Flannel, Flannel is a container-focused network connectivity solution. So it's meant to allow containers to get layer 3 IPs across either a overlay network, which Flannel can implement itself, overlays built into the kernel like VXLAN, or use things like Amazon VPC or Google Networks. So the point of Flannel is to help you make sure all your containers can talk to one another. This is a particularly difficult problem when you're using Kubernetes, because every single pod, thus every single set of containers that gets deployed, gets its own IP address. So you might end up with servers that have lots of IPs, physical servers with lots of IPs attached to all the different pods. So we built Flannel, again, in the spirit of build into the void. There wasn't a solution that worked well for this use case, and so we built Flannel. Again, it's an etcd-backed container connectivity solution. In Kubernetes, very recently, we have a new object, a network policy object. It's been in alpha in 1.2, and you can think of it like Amazon security groups, but really on steroids and completely dynamic. So it's kind of the way security groups should work, focused at a container level instead of a host level. So we have in alpha right now. It's implemented through a third-party resource in Kubernetes. In 1.3, which is pending, it should be incorporated as a native object. Now, there's Project Calico, a company that is a project that has been long-time kind of collaborators with CoreOS. They are the leading implementation of this network policy. They did a lot of the upstream development to get these objects into Kubernetes in a generic way, and then have gone and implemented implementation in order to enforce these network policy rules. So what we have today and what we're announcing is that we are bringing both of these projects together under one tent. And we are cleverly naming it Canal. So it's what happens when you bring together the connectivity parts of Flannel with the Calico network policy management pieces. And it's a new project, so new that Andy, the GM of this project, just had to change his shirt out from a Calico one to a Canal one. But this is a brand new initiative where we're jointly working with the Calico team in order to bring this as a unified solution. So I'd like to bring up Andy to give an overview of the project.
Great. Thank you. Thanks, Alex. Thanks so much, Alex. And it's fantastic to be here in Berlin, to see so many people gathered around what we're all trying to do here around this Giphy initiative. And in fact, I remember the first time I came to Berlin was just after the Berlin Wall came down. And back then, there was this huge difference between East Berlin and West Berlin. It was like two different cities that had a wall between them. And over the last 25 years, it's been amazing to see how they've merged, become one, and become this huge, vibrant global city, and the powerhouse of open source in many ways as well. And I like that because it's very symbolic of what we're doing here with Flannel and Calico. So the vision here, this is what it's going to look like when we're done with Canal. Not that we'll be done, but where we're moving towards. We'll have a single CNI plugin into Kubernetes, and then below that, Calico implements policy, and Flannel has all the multiple backends that it has today, and a few more that it's going to get from what we currently implement in Calico. So we have a single unified solution, all backed by etcd, integrated into Kubernetes, and by extension integrated into Tectonic as well. So this is where we're headed towards. We think this is something that the user community is really going to embrace. In fact, a large part of the reasoning why we got to this point of agreeing to do this with CoreOS was because we had the end users coming to us as in Calico saying, we'd like your policy stuff, but can we use it over Flannel? And Alex came to me and said, we're hearing the same thing as well. So we do believe this is something there's a lot of pent-up demand for out there among the user community. And the other reason why the timing of this is so important is I think a lot of the early deployments of Kubernetes to date have really been very early trials. People are just getting the hang of it. And as we go to full-scale production, people are much more concerned about how do I do security, how do I implement policies across a large infrastructure. And so the timing of this is just right in terms of where the market is at and the development of the market, as well as obviously the implementation in Kubernetes itself. And what it means is for users and for developers, it means there's one go-to place that's the best of breed implementation for open, secure cloud networking. It's the de facto standard. You don't have to say, am I going to use Calico, am I going to use Flannel? That decision's gone now. You just use Canal and you get the best of both worlds. And from the developer's perspective, from our team and from the CoreOS team, it means that we don't have to duplicate resources, we don't have to be implementing things in Flannel and Calico. We just focus on whatever's best for the integrated project and whatever's best for the community. So we think this is a real win-win, and we're really excited about it. And just a word, because some of you may be users of Flannel today, some of you may be users of Calico today. In fact, I know some of you are. This doesn't mean that those projects are going away. They will continue to exist and have separate lives, but as part of this Canal initiative. So, leads to the question, if there's two companies involved in this, putting it all together, obviously CoreOS has Flannel, and for those of you who are familiar with Project Calico, we're sponsored and homed right now in a company called Metaswitch Networks. How do Metaswitch and CoreOS kind of put this together? Well, the answer is, after some work on what was the right way to structure this, we decided to set up a new company specifically to take this project and take, in fact, all of these projects and be the maintainers for Flannel, Calico, and Canal. So we're really excited today to announce that Tigera is the new standard solution for secure cloud networking. This has been a few months in the making, as you can imagine. But we're actually launching this as of today. And we think it's really important for the community to be involved in this. So, we've obviously put a lot of the work into this together with CoreOS, but we really are encouraging all the developers who've been involved in these projects to embrace this and to collaborate. The other thing is this is done obviously together with Metaswitch. So Metaswitch has actually contributed the Calico project into Tigera and contributed the team, and so the team is moving from Metaswitch into Tigera. So there's absolute continuity of support for existing customers, and all the know-how is going forward with this. And I'm also excited to say, as of today, we're not just announcing the company, but we've also closed our Series A financing, which gives us a pretty extensive runway to kick this thing off and really start to put some real resources behind it. So we think this is a great foundation for the vision that we have for secure networking in the cloud. So that's obviously just a little taster of what we're doing here. And I do encourage you, there's a breakout session tomorrow. I'm sure the parallel ones would be great, but this is the one to get into if you can. We're going to have our VP of Engineering, Alex Pollitt, who many of you will know, together with Brandon Phillips, who I hope all of you know, talking about the work that we've done to date, and kind of what is there right now, and how we're going to be taking that forward and the vision in a lot more detail. And we can do a demo because this is something that's implemented now. We just got it integrated into the CoreOS Kubernetes distro, and you can go download that as of today. You might want to go to the session tomorrow and find out a little bit more about it and see the demo, but do download it, try it out. It's essentially a preliminary integration of Calico and Flannel, but it's working, and you can use the Kube AWS tool within the CoreOS repo there to just go try it out, and it'll install it all on AWS, real easy to use. And you can, if you want to get into more detail and try it on other platforms, you can go in there and see the scripts and see how it's all done. Okay, so that's our announcements for today on open and secure networking, and I'll hand back to Alex. Thank you.
All right, congratulations. Second financing of the day, and a new kind of de facto container networking solution. Okay, next thing I'd like to talk about is a capability we released at the end of last year called distributed trusted computing. So we believe that this architecture, this Giphy style of infrastructure enables security patterns that haven't been done before. And one of those is this concept of distributed trusted computing. What this is end-to-end integrity and trust. It allows us to verify that the machines that you bring up and running are the ones that you expect them to be, even if they're running in third-party data centers. And it uses technology such as Secure Boot and the TPM, or the Trusted Platform Module, to make this happen. So this is a great technology, but to date, it's been a little bit difficult to get up and running. And so we're talking about how we're making this much easier and more accessible to folks. And to do that, I would like to bring up Zach, the CEO of Packet, which is a leading bare metal as a service cloud provider. So thank you, Zach. And I'm gonna stay here. I'm going to stay with you on this one.
Yeah, let's not let Alex walking down anymore. He's getting a little tired. Well, first off, thank you. My name's Zachary Smith. I'm the co-founder and CEO of Packet. We are a bare metal single tenant cloud platform built for developers, primarily for cloud native stacks. You can see we're the little one down there, at least in my crude drawing. And so we already took the poll earlier about who's running in a public cloud or third-party data center. So who's not running anything in a third-party cloud or data center? So there's a few, right? I know, it's the first person actually I met here at the conference does not do that. So a quick little background on myself. Why start a cloud provider? My core reason was to build a better internet, very similarly aligned with the guys here at CoreOS, and I felt that the most important thing was to build fundamental infrastructure that was more reliable and more fungible. And the next thing that you would go along that path is to build more secure building blocks. So the first operating system that we supported at Packet was CoreOS. It's a way to build a more secure internet. But now with distributed applications becoming more and more popular, used in this kind of manner, we have to have a different way to manage our security and enter Tectonic. So the quick question is, why should we trust all the things? And my answer, do you trust me, your friendly neighborhood cloud provider, that your machines are as I say they are, that I'm using all my good security policies to not let anybody in the door or to infect your machines? And I would say the answer is easily no. Since most of us are deploying into third-party data centers, we really need to find better solutions. And luckily, this little chip here, the trusted platform module, it's in billions of devices, probably not billions of servers, but more like hundreds of thousands or millions of servers, but it's used by very few of us. And so I'm really excited that Tectonic, took that extra step, and it's quite a lot of engineering work to make this happen from all the way on the boot on up. But let's quickly just, do a recap for those who weren't at Tectonic Summit in December and talk about what is trusted computing and how does it work. The TPM module is essentially a foundation for a chain of trust, and distributed trusted computing leverages that to perform validation from the time that the server is booted on all the way up through the cluster management, right? So at every layer, essentially validating the integrity of your system. And this is a whole new layer of security and a way to run these distributed apps. The problem has really been, as Alex pointed earlier, it's not so easy to get up and running. So what we'd like to do is do a little bit of show and tell. Alex is like the demo guy, right? So I'll leave it off to him if we can flip the screen. And we'll show a quick cluster run of this.
So I'm going to give you a little bit of preview of what we've been working on. So this is our same little OpenStack cluster we have running. But I'm going to flip over to the Kubernetes pods here so we can go look at the API server itself. So this is the API server for Kubernetes, shown as a pod, a little bit inception going on. But if we click on the logs over here, you can see it's a little bit hard to read for those in the back, and I'm sorry. But what's happening here is you're seeing a TPM quoting process happen. And this will continue to stream in. So we're constantly validating the nodes' current state of their TPMs in order to know that nothing's changed on the machine. That means the firmware, the BIOS, the OS itself is in a high degree of integrity state that you can trust. And by doing this, we can say, hey, if this machine joins and it attests correctly, then that's what gives it your workload and your secrets and your containers and so on. And by integrating this with the Kubernetes, it is a seamless, general purpose solution. It almost happens transparent to the user. If someone gets in there and modifies your bootloader and you don't know it, the machine just won't boot or won't be able to join the cluster anymore, and your workload will move over to another machine. And so the combination of the distributed systems and the enhanced security is what makes this possible. So I wanted to show a little bit behind the scenes. So this is the API server validating, but just thought it'd be fun, raising financing one day and doing console demos the next, to give you a little bit of background on what's going on here. So this is a normal bare metal server on Packet. They have TPM devices. In there you can go and launch a Packet instance, and it has TPMs in the set of machines that if you request that. You can go in and just cat the sys device in the kernel, and you get all these values out. Again, you might do this on your laptop if you're running Linux, and a lot of modern equipment has TPMs built into them today. All these different values are the checksums of the different stages. So I don't know exactly which is which, but one of these is the firmware, one of these is the bootloader, one of these is the image itself. And we've extended Rocket so that when we run containers, we're additionally logging these values into the TPM. So every single container you run through the environment also gets logged. So you can really prove cryptographically that these machines are in the state that you trust. I think if you were to go cat yours today, it probably would just read zeros everywhere. And the reason that they light up here is because CoreOS itself has all the different integrations at every single layer to log these values correctly. And that ships in our alpha images, or not alpha, they shipped in alpha maybe a month, 45 days ago or so. So it's been in there for a while. But so that's what's going on there. If we go to the Kubernetes side, I'm in a configuration file here, and I can cat one of these values. This is what Kubernetes is looking for. So it is the Kubernetes API server is configured, and these are pre-known values that you can trust ahead of time. That then causes Kubernetes to reach out and do this attestation process so that it can verify before adding the node to the cluster. To do this, we've been really focused on keeping as close to upstream as we possibly can. And so I have kubectl here. This is just the latest version of kubectl. You see, again, my instances there from that OpenStack cluster that we're running, and it's this host. But if there's a capability in Kubernetes called third-party resource, if I get it here, you'll see that there's one in here. This is how we're able to extend the Kubernetes API without necessarily forking it or having a different version. So I have this third-party resource in here, TPM, and that allows me to, just like I could go get pods above, I can go get TPMs and query those natively out using an upstream, kubectl. I can go and get a TPM, and I'm just going to print the YAML so you can actually see the raw object underneath. And the things, if you're familiar with trusted computing, that you'll notice are like EK-cert, AIK, blob. AIKs and EKs are how a TPM gets its identity. So it uses this identity to do signing operations, and it's part of that cryptographic remote attestation process that makes all this happen. And we're able to extend this directly into Kubernetes by augmenting it through this third-party resource capability. So it's an example of how you can take upstream Kubernetes, but also extend it to do these unique things, like we're doing with the distribution in Tectonic.
So if any of you have actually implemented an environment using TPM, you'll notice that this is pretty well put together. It's a complete solution, but it's still really complicated to get going, right?
Right.
So for that,
we're actually still on the demo.
One more demo, not yet.
Well, a little bit more demo. Not done yet, folks. So we need to make this a lot easier. In fact, provisioning Kubernetes itself without all this TPM stuff can be pretty difficult if you've tried to do it. More difficult than it should be. And so today we're announcing another company. Unfortunately, the CEO of this company can't be here today, but StackPoint Cloud is launching today, and they are aiming to make it extremely simple to launch Kubernetes clusters. And as part of that, we've also worked with them to allow you to easily stand up these distributed trusted computing clusters just with a few clicks. So I'll just go ahead and do it really quickly. I'm going to go and create a cluster. You can see that you can do this on Amazon, DigitalOcean, and Packet currently. And again, you can do this with upstream Kubernetes or the Tectonic bits. We'll pick Packet, of course.
Thank you.
You can see I can go and select some nodes. These type 1s, type 3s are pretty beefy machines if you need a lot. What's in a type 3?
A bunch of NVMe.
Okay. So I'll pick our key from Packet. We'll go ahead and launch this in
why not?
Marlboro Music. Okay.
They want a Kubernetes cluster.
I can go in here and you can see I can choose which version of Kubernetes I want. You can pick a Linux distribution. There's only one at this point with StackPoint Cloud, of course. And you can choose different solutions. So you can just go straight up vanilla Kubernetes if that's all you want, or you can launch Tectonic, which includes, for instance, this trust community stuff. We'll do that. And then on the security front, you can turn on the TPMs if you want. This will cause the system to select the packet servers that have TPMs and wire up everything for you. So we'll go ahead and turn that on. We're going to take Zach's key set, and then we'll go and submit it.
Why not?
Off to the races, and the cogs are now busy making the Kubernetes cluster on Packet.
Making the secure Kubernetes cluster on Packet, no doubt. Well, thank you for that, Alex. It's awesome to see how that's been done. By the way, we can switch back. It's going to take a while.
Booting some bare metal servers. But it's hands off at this point.
Yeah, there we go. So this is the point, right? Is we're trying to democratize how trusted computing gets to everybody. Just trying to make it super easy, make it fast, make it affordable. And I'm really proud to be working with both StackPoint and the CoreOS Tectonic team to make this happen. So as of today, you've got the world's first on-demand distributed trusted computing platform. That doesn't mean that I have a platform. It means you can build your own platform on Packet. So take our bare metal nodes, use TPM or don't. Takes about 30 minutes to build and configure a whole cluster, and it costs about $1 an hour. It's available in Amsterdam, New York, and California, and there's options for on-prem. And I think the takeaway here is that we've really removed a lot of the excuses, but what says good, like free, So you can get some credits from us. The Tectonic team, allows you to take the starter account, if I'm correct, right? And you can use the keys from that, plug it into StackPoint, which has no cost to you, and get your Kubernetes deployed with or without TPM, either way you want to do it. All right? Thank you so much.
Thank you, Zach. Thank you. Appreciate that. Okay, lots of stuff. So, just to recap all of this, we today announced Canal, which is bringing together the connectivity from Flannel with the network policy of Project Calico into a new project. We showed you the first ever trusted computing cloud. I mean, it's the first time this has really been done. We are working with more to try to bring this out there into a bigger concept, but it's available today. We launched stackpoint.io, and you should go try it out. They are quite possibly the easiest way to get a cluster up and running with Kubernetes on AWS, DigitalOcean, and now Packet. We open sourced Stack and Kubernetes through the work that we've been doing with Intel, and we announced our $28 million in financing to continue on our journey to secure the internet. So, I would just like to say thank you so much for all your participation, and we're looking forward to everything that's next.